to another class in LearnCity. My name is Praise, and in today's class we'll be talking about sequence and series. Now, what is sequence? A sequence is a list of numbers that follows a rule. A sequence is a list of numbers that follows a rule. A sequence can basically be 1 to 2 to 3 to 4 to 5 to 6 till the end. Now, examples. Find the next two terms of the sequence of these questions. We have the first one, which is 3, 7, 11, 15, 19. Now, this is a sequence which is a list of numbers. Now, the difference between 3 and 7 here is 4. The difference between 7 and 11 here is 4. Here is 4. Here is 4. So now the next two numbers will now be 19 plus 4, 19 plus 4, and plus 4. So we have it to be 19 plus 4, which is 23, and 23 plus 4, which is 27. So we have it to be 3, 7, 11, 15, 19, 23, and 27. Now, for 1, 4, 9, 16, and 25, we have 1, 4, 9, 16, and we have 25. Now, the difference between this one is 3. The difference between this one is 5. The difference between this one is 7. The difference between this one is 9. So automatically the difference between the next, we can see that the difference here is increasing by 2. So definitely the difference between the next one will now be 9 plus 2, which is 11. That will be 25 plus 11 will now be 36. So the next one will now be 11 plus 2, which is 13. That will now be 36 plus 13 will be 49. So our numbers are now 1, 4, 9, 16, 25, 36, and 49. The next one says 1, 1, 2, 3, 5, and 8. The difference between here is 1. Here is 1. Here is 2. Here is 3. Now, the difference between that one will now be 4. So we have it to be 4. That will be 8 plus 4. That will now be 1, 2, 3, 5, 8, 12, and 17. So we have it to be 1, 2, 3, 5, 8, 12, and 17. So here we have it to be 81, 27, 9, and 3. So here, when we divide through, this is divisible by 3. Here is divisible by 3. Here is divisible by 3. So when we divide this by 3, we have it to be 81, 27, 9, 3, 1, and 1 divided by 0 is 0. Now, we've gotten the next two terms of the sequence, and also it is important to know that the nth term of a sequence is known as Tn or Un. Is known as Tn or Un. Now, the nth term of a sequence is the term from which all other terms can be generated using natural numbers. The nth term of a sequence is the term from which all other terms can be generated using natural numbers. So we can either have it as 1, 2, 3, 4, 5, 6, 2, n. So as the number progresses, since you don't have where the number is stopping, you have it to be represented as n. Now, examples. The nth term of a certain sequence is given as Tn times 3 raised to power n minus 1. Now, write down the first three terms of the sequence. Write down the first three terms of the sequence, and what is the nth term of the sequence. So what is the nth term of the sequence? Now, we have our Tn to be 3 times 2n minus 1. Now, for the first term, which is T1, we now have it to be 3 times 2, 1 minus 1, where n is 1. So we have our T1 to be 3 times 2 raised to power 0. And anything raised to power 0 is 1. We have to count 3 times 1, we have it to be 3. So our first term is 3. And now for our second term, we have it to be 3 times 2 n minus 1. We have it to be 3 times 2, 2 minus 1. 3 times 2 raised to power 1. We have it to be 6. We have it to be 6. Now for the third term, where n is 3. 3 times 2, 3 minus 1. 3 times 2 is power 2. 3 times 4, over T3 to be 12. So the first three terms are 3, 6, and 12. Now for the nth term, for the 10th term, so when n is 10, so we have it to be T10 will now be 3 times 2 n minus 1. We have T10 to be 3 times 2 10 minus 1. 3 times 2 raised to power 9. And 3 times 2 raised to power 9 is 2 times 2 4, 4 times 2 8, 8 times 2 16. 16 times 2 is 32 times 2, this is number 6. Then for 7, for 8, 1, 5. And for the 9th term, you have 12, 1, this is 10, 11, 1, 5. We have it to be T10 to be 3 times 5, 1, 2. So now 3 times 5, 1, 2, we have it to be 6 and 15. So we have our 10th term to be 1, 5, 3, 6. So therefore, the 10th term is 1, 5, 3, 6. So we've gotten for the 10th term. The second example says, find the nth term of the sequence 2, 6, 10, 14, and 18. find the nth term. Now, if we look at this very well, what is the difference between the two? This is 4, this is 4, this is 4, and this is 4. So basically, it can either be 4n minus 2 or 4n plus 2. So that is what we are going to try. Now, we are going to try it till the fifth level just to check if you are correct. Now, for 4n minus 2, when n is 1, so we have it to be 4 into bracket 1 minus 2. This is 4 minus 2. We have it to be 2. Now, when n is 2, we have 4 2 minus 2. This is 8 minus 2. We have it to be 6. When n is 3, we have 4 into bracket 3 minus 2. This is 12 minus 2. We have it to be 10. When n is 4, we have 4 into bracket 4 minus 2. This is 16 minus 2. We have it to be 12. This is 14. And when n is 5, we have it to be 4 into bracket 5 minus 2. We have it to be 20 minus 2, which is 18. So basically, when we use 4n minus 2, we got our 2, 6, 10, 14, and 18. But if we use 4n minus 2, 4n plus 2, when n is 1, 4 into brackets 1 plus 2, that is 4 plus 2, that will be 6. So basically, our first number will not be 6. Now, for our nth term, we know that our nth term is now 4n minus 2. That is our nth term. Now, for the next example says, also find the nth term of the sequence 2, 5, 8, 11, and 14. So we have here to be 3, here is 3, here is 3, and here is 3. So basically, what can we use? We can use also 3n plus 2 or 3n minus 2. Let's try 3n plus 2. When n is 1, this will be 5. 3n minus 2. When n is 1, this will be 3 minus 2. This is 1, which is incorrect. So let's try 3n minus 3. When 3 is 1, this will be 0. Let's try 3n minus 5. So 3n here will now be 3 into brackets 1 minus 5. We have it to be minus 2. We are almost there. So basically, what we can use is 6. Let us try 6n minus 4. So where we have 1 minus 4, this is 6 minus 4. We have it to be 2. Let's try 6 when n is 2 minus 4. This is 12 minus 4. We have it to be 8. When n is 2, we have it to be 8. 6, 3 minus 4. This is 18 minus 4. We have it to be 12. And here we have 11. Which means we cannot use 6n minus 4. Now let us try 5n minus 3. Let's try 5n minus 3. We have 5 here, 1 minus 3. This is 5 minus 3. This is 2. Let's try for 2. This is 7. Let's try for 3. This is 15. We have it to be 14. So basically, all these do not work. So now, what will be the end term of this sequence? Where we have 2, 5, 8, 11, and 14. Now, since the rule is we have 3, since the rule is 3, so we have it to be 3n. So we have 3n. Now, what do we do when 3 is not working, 6 didn't work, 5 didn't work? So 3n is when n is 1. 3 times 1 is 3 minus 1. This is 2. Let us try when n is 2. So we have 3 into 2. We have minus 1. We have 6 minus 1. We have it to be 5. So basically, our answer will now be 3n minus 1. So when n is 1, we have 3 into 1 minus 1. We have it to be 3 minus 1, which is 2. When n is 2, we have 3 into 2 minus 1. This is 5. When n is 3, we have 9 minus 1, which is 8. When n is 4, we have it to be 11. When n is 5, we have it to be 14. Hereby getting our number 2, 5, 8, 11, 14. So in cases like this, we try different numbers to get our answer. So the end term of this sequence is 3n minus 1. That is the end term of the sequence. And defining series. A series is formed by adding the terms of a sequence, e.g. 3 plus 6 plus 9. So that is a series. And now we have two types of series. We have the infinite series and the finite series. So when we have numbers like this, dots, 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 that is called an infinite series, which means it continues. And for the finite series, we have it to be like 3 plus 6 plus 9 plus 12. That is a finite series. That means it is stopping at a particular part. But for the infinite series, it continues to the end. And this brings us to the end of our class on sequence and series, in which in our next class we'll continue more on arithmetic progression. Subscribe to our YouTube channel, like and comment, and I'll be seeing you in the next class.